Let's start here. Today we will go through some terminologies and concepts. Okay, in Redshift,
Okay.
like there is some terminology like slice, block, zone maps. Then there is a concept called distribution style, and then columnar storage. You know already. Then we have this compression encoding. So a column can be compressed by some methods. So that we'll also see. And then we'll see how to create the account um, in Amazon. Okay. Then we'll also see what are the softwares you would need, and we'll try to download that, and we'll try to use them. And then we'll log into your account, and we can uh, will basically install your workbench software, and we'll start working with one workbench. Uh, we'll create. We'll also download one S3 browser, as I told yesterday. Okay, which will be used for actually viewing your files in the S3 storage. We can work very easily with that tool. Then we'll create a IAM role. We'll see one more service called IAM role, where you can give the access to your clusters. Sorry, you can give actually access to your. Suppose you want to connect to another service from Redshift, like S3, then you need to have a user, a role created for that. Okay, we'll see about that. So for that, we need to use one IAM service. Then we'll create clusters. Um, then we'll see we have to create one security group. Then we'll launch your SQL. We'll try to connect to our cluster. We'll do some table creations. We'll insert records and see how it is inserted in the Redshift, how the records are getting inserted in the Redshift. And then we will also use a copy command to copy your data from Redshift to S3 to Redshift. And there is unload command also, from where you can copy your data from the Redshift to S3 storage. Okay, so we'll see how far we can go in this agenda. Okay.
Okay, Rajiv.
Okay, I'm sharing my screen. Are you able to see my screen now?
Yes, Rajiv.
Okay, so if any questions or doubts, you can always ask me. Okay.
Sure, Rajiv. Yeah.
Okay. Yesterday we have seen, what is cloud computing, why AWS, what is Redshift, what is the benefit of Redshift, and we also saw the architecture of Redshift. So, any questions in that up to now?
No, Raju. Actually, I also done some. I have gone through some videos, and what you said, I also seen that how to create an account, everything.
Oh,
As
great.
of now, no doubts. Yeah.
Okay. So, have you
Mm.
started your issue is solved with your account?
Yeah, it's all. But again, we will do once again because I have some. I confused by doing that account. Because I
Okay.
have done with the help of in Amazon, we will be having the documents right
Yeah,
to
yeah,
get
yeah.
start.
Correct, correct.
Yeah, I
That is a great way
yeah
to start, actually.
I did that.
Hmm.
Yes, so
So,
I started doing that.
so were you able to
But
create the cluster?
yeah, I also created the cluster too.
Wow. Okay.
Hmm.
So up to what
So the
stage?
thing is, I did that in my client system actually. I mean, in my office.
Hmm.
So I thought of doing that in my personal system too,
Hmm.
because I am unable to download this SQL in my office system. So that's why, that is the reason. So I just created the cluster and I left over there only.
Okay. So, in your office, like, did you also work with this SQL workbench then?
No. That's what I'm telling. It was not there. SQL workbench. It is not there.
Okay, and so you could not install it. You could not download and
Yes,
install in
correct.
your
I
office.
stopped
That's
there.
all.
Yeah.
Up to
Yeah.
that, you stopped. So that means you already know how to
Yes.
create a cluster, how to give the access roles and everything, right?
Yeah, everything, but it's better if you explain me once again, then I can clear my doubts if I have anything.
Okay. So
Yeah.
that's good. That's good to know up to what comfort level you are.
Yeah. Yeah.
So I think it's good only. If you are going through the documentation and you're actually started
Yeah,
working,
I'm going
it
through
is
from morning. Yes.
it is very
From
good.
morning I'm doing that thing only because I am I'm going to office and I'm watching the videos and I'm trying to explore something from that Redshift.
Very good, very good. So
Yeah.
it is good to know that you started using it. So
Yes.
and you are coming to know. So is that
Hmm.
yesterday's session helped you in understanding more?
Yeah, it's yeah, I got.
Okay, good. So today then we'll go through some concepts. Okay, we can actually quickly go through concepts.
Okay.
These are nothing but more architecture, more towards the architecture, right? What are the different, what is a slice and all kind of things. So we'll just go through that, and we'll go and create account and start working with clusters as you already done. Okay,
Okay.
just to understand some terminologies again. You have a compute node. You already know what is a compute node, right? It is where the
Yes.
data is stored and it is executed. So compute node is of again types. There are two types of compute nodes, as I told you, right? Uh, I mean, two types of nodes. One is dense storage and one is dense compute. Okay, so depending on the type of the node that you select, okay, for your clusters, compute node will have some kind of number of slices it gives you. Slices nothing but it's a partition. You think this as a partition in your if suppose you have a hard disk, right? So you divide the hard disk into two partitions. So in this terminology it is known as a slice. You think just like that only. So there's two slices. So when you take an account and you use your DC node, which is free, okay, which you can use only one node. In there you will get two slices because the size is limited. Okay, 160 GB you'll get two slices. Suppose you go and increase your size, then you may get even 16 or 32 slices depending on the node type. Okay, you just think that again this is having its own memory. Okay, it's a again it's a virtual computer, you can just think, and has got everything in it built in, uh, like a single hard disk, you think. Okay, so you will get two slices, so the data gets distributed. See, you already know the distributed file system, right? So when you insert the records, your table rows and all, they will be distributed among these two. Uh, you can think as a virtual node. So two nodes, it will get distributed automatically. Okay. Then there is something called blocks. How the data is actually written inside. Okay, table gets distributed among. The main aim is distribution only. If the more you distribute the data, the more parallelly you can fetch the data, the more fast your things, the parallelism will come into effect there. But suppose you don't have distributed and you have everything in one, then it will be as slow as what normally we do. So data is stored as blocks. Your column data, because it's a columnar database, so your data gets stored in columns. Okay, and your column again is divided into number of blocks. Okay, a block is of 1 MB size, which is immutable. That means it cannot be changed once it is written. So how your update, see, how your update and delete command works is something like when you do an update, it will uh, uh, it will do two things. One, it will mark the row for deletion. Okay, this row gets marked for deletion, and then there will be a inserted, that updated row will come here. And if you just delete a row, it will be just marked for deletion. So actually it will not change the block once it is written. Okay, there is some methods by which it does that. So there is some vacuum command which will remove the ghost rows once this is done. This is just to make the things faster. Okay, and as you know, data warehousing concepts where the once it is written, it is immutable, right? So to free up the space, we need to use the vacuum command. Okay, and each block, this just methods to reduce your IO operations, as I was explaining. So each block contains in memory metadata. So that is nothing but zone maps. We'll just see what is zone maps. Okay, that this also will help you to reduce your IO operations. How it works, we'll just see in a moment. Okay, and each block contains its own metadata uh, called zone maps, and then it contains the link between the different nodes. So all the blocks are linked together. Okay, and they are uh, they each block can have the compression. Each There are some compression methods. We'll just see that. So uh, each block can be compressed by different ways. So column compressions are there. As I told you, explained you, a column can be compressed. Okay, so that okay, here it is. See, we have seen that. So each column, can be having its own style of compression. Okay, we'll see the compression styles and all. Okay. So this is all about blocks. So actually, basically, a column is stored as a set of blocks. You can think, and each block is got its own metadata, which is so block size of the column would be only 1 MB.
Raju, just a second. I'm
Sure.
connecting from my laptop because I connected through my office laptop again. Just give me a second. I'm logging in. One
Okay.
second. Because when it's totally it's switched off, so that is the reason I logged in from office system.
Okay. Yeah. Hello.
Yeah, you can go.
Hello.
Yeah, are you able to hear me?
Yeah. Yeah. I am able to hear
Hello?
now. Yes. Now I am able to
Okay,
hear.
okay. Yeah. Okay.
Okay, so what I was trying to tell is block concept. Okay, so as the data gets stored in a column manner, each column is again divided into a set of blocks. Just think as a small area where it can be again compressed. Okay, and one more thing here, we have one more concept, as I told you in that IO operation reduction. We have something called a block again can be, you can have two sets of blocks. One is a unsorted block and a sorted block. Okay, that you can decide what column can be a sort key, so that it uses this mechanism. So what it does is actually it maintains two set of blocks that is called as block chain. Okay, one is unsorted block, means once you do a update or a delete command, this it the record gets stored in the unsorted block, and it it gets sorted or it gets merged. Why it maintains two means because if you are trying to search the data at the same time, somebody is trying to search the data, somebody is trying to insert the data. So when you're trying to search and it is already sorted the form, you already decide this column need to be sorted. So in that case the data retrieval will be faster, and it gets merged when you do the vacuum command. So there is some techniques it uses, so it maintains actually two sets of blocks inside the same block. One can be unsorted, one can be sorted. Okay, but all columns need not be in sorted. It doesn't have to maintain two blocks inside it. It can be only single block, which could be unsorted block. But anyway, this vacuum will clear the space. Okay, when you do delete command. or an update command. Then there's something called data distribution. Okay, data distribution is there is a style called this style, which is actually table property. For example, something like this you can give when you create a table. Okay, so you can use different distribution styles. This will, the main goal of the distribution is data gets evenly distributed. So this is a parallel processing happens. Because of this, you can actually minimize the data movement during the query. So if you decide one column as a key column, which should be distributed in the slices. So what it does is, there are three concepts here again. There's a key, all, and even. So you can just give this as, you can decide a column as a key to get the data distributed, okay, evenly. So if you don't distribute the data evenly, so then again, if everything is stored in one, then it takes larger time. So more IO operations need to take place. Here, if it is divided, the goal is, if it is distributed evenly, then it takes less time to process. So that is the advantage. Okay, so key is nothing but you can decide uh, a particular key on which the data needs to be distributed, and you need to be careful what kind of things you need. So this all comes in your best practices of creating and working with your database. Okay, so this key is very useful for columns with high cardinality. You know what cardinal values?
No, Raju, can you tell me one?
Okay, see, uh, cardinality is something like if you have let me just see, let's say there is a um, okay, you have the IDs, right? That is a primary keys. So the primary key will be all unique keys. So if you have the unique key, let's say this is ID key, okay, uh, and you have let's say you say male and female. You have a column called sex, where you have the male and female, okay, or they can be other one, but it is always it will always have these two values. But when you come to this ID, so this could be something like this, your data could be something like this, right? So you see, this will have only two values. So the cardinality means the number of distinct values that a column would have. Okay, so in this case, the distinct value would be 2, right? And in this case would be 6. That means we call this as a high cardinal value. This column has got very high cardinal value, and this is a low cardinal value. So if it is a high of high cardinal value, then data would get distributed as per your number of slices, which will be very fast. Uh, so main aim is data distribution. So distribution should be even. So in this case, if the cardinal value is 2, then at the most it can go, data can go into your 2 slices only. Okay. But if the cardinal value is 6, it will depends on 1, 2, 3, 4, or 5, 6. So it will get distributed more if you have the cardinal value is more. So basically we use this key for we choose the column which will have a higher cardinal value. You got the idea?
Yeah, Raju.
If the value is high, means that means they are less unique values. It gets distributed more evenly across all your slices. That's the
Okay.
basic idea.
Okay.
Got it? Okay. So if you're when you're designing a table, you need to decide which column you need to decide as a dist key or distribution key. So based on this ID, it gets distributed. So you need to choose a proper this thing. So if you choose the other one, as I told you, which is having less cardinal value, it may not go in evenly and distribute of all this thing. Okay, and the advantage of this distribution is this column, the same. Suppose this column, so all this column will be equally distributed, and it will be all available in one location or one slice. It will try to distribute it, uh, the column which you decide, all in a single slice. Okay, so that IO operations can be reduced there. And there is something called all. So when you design the table, you can also give something all, where this is useful for smaller dimension tables like your customer table, product table, dimension and fact tables, right?
Yes.
Okay, so there is a small dimension tables, where you can have the product ID, customer table, and all those things. You can decide. So in that case, entire table will go to the first slice of your different nodes. Okay, so entire table will be available because you don't have to, run many queries on that. It will be just seek for just getting small data, or you'll be using very less. Okay, so for that you can actually store all the table in, it gets stored in, entire table gets stored in a single slice, but again it is distributed, so it will go into two. So it will have a copy, two copies will be maintained in two different nodes. Okay, and if you can't decide which column needs to be key column, distribution key column, or you can't decide which, then you can, by default it will do a round robin, means each record it will try to send here, 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 and here. These are some concepts, okay, which you can use while designing your tables. Okay, so the way to give that is you just give a disk style, and here you just give all, and here you need to give disk style key and distribution key. So give the column, which column you want to use for your distribution of your records, and this is the default. Even if you don't give, it will get distributed evenly. And this you already know, column storage, so I don't have to go about it. Okay, and data compression. Okay, this Redshift uses a compression techniques. Okay, there are different compression techniques, and you can decide what kind of compression techniques you want to use. This is also the concept where you want to design your table structures and all for efficient use. Okay, so why we use compression. First of all, see, like zip files and all, you have a large size, and suppose you store in a format of a zip and RER and all those things, then it will be more advantages, like the space it will consume less. So similarly, it applies. You can apply these concepts on column. So if the column takes less space, less time it will take for retrieving the data. So it uses some concepts, and you can decide which column needs to be compressed in what form by this method called encode. Okay, you need to suppose there is a LZO method by which you can compress. So you need to give a column, data type, encode, and that particular method by which you need to encode. So there are different methods of compression. We'll go through this encoding and just try to understand what are the different methods. Basically, it is to reduce the IO operations. Okay. And coming to zone maps, this is one concept it uses for distribution, and in fact for reading. Uh, it is when you actually store your data, it uses a concept called in-memory blocks. See, as I told you, blocks, right? Block is containing a metadata, so it contains one in-memory block metadata. It is uh, so when you have a block, let's say this is a block. Okay, how, as I told you, there is a unsorted and sorted, right? So your data, let's say, is stored in this way. So this is a row, let's say, and in this row we have a column called data of joining. And this data of joining, when you insert the records, let's say you have given in this way. So this is how data is getting stored. Okay, and you have given its distributed key, so everything is coming in this order. So everything is available in this, which is unsorted order. So now you're trying to give one command. Let's say you're trying to give aggregate command like count command, and you want to count all the employees where date of joining is 13th Jan. Now you see the data gets distributed like this, and let's say there are two blocks of 1 MB. See, this is very small data. You think that it is a very large data, okay? And each block is of 1 MB size. So there are, let's say there are two blocks, okay? And what the zone map will do is it will automatically, when it creates a block, it creates a metadata wherein it stores a minimum and maximum value in that particular block. See, block is a column, okay? You think column is a block. So for that column, in that block, what is the minimum and maximum value? It will try to store. Actually, it stores as a metadata information automatically. So this will help you in queuing your data and trying to retrieve your data. But suppose you have a data called like this, and it is in unsorted order. So if you see this, how the data gets stored is, see, there is a 12th Jan and there is a 18th Jan, which is min and max value. So it works best, when you have this kind of columns like date columns, and where you want to do some aggregate functions. So you can actually, you can do the compression methods, and you can do a sort. You can actually give a sort key for this column. That will be very easy, and you can use this zone maps very effectively with this sort key. Okay, that means you can decide this date of joining column as my sort key. Okay, so what it does is, as I was telling, it stores minimum and maximum value automatically. So in this case, it is 13th and 17th Jan. So when you try to give this command, right, 13th Jan, so what it will do is it will try to see, it will first look into the minimum and maximum value in the metadata of that particular blocks. It will go through all the blocks, okay, metadata, and try to see where this data is located, because it needs to retrieve the data. See, it doesn't have to, again, a column is, entire column need not be read, okay. The data is present. Why this zone map is, if the data is present in only particular blocks, only that blocks will be retrieved. Not, no need to thousands of blocks search, or entire blocks to see where the data is. That is why it maintains this minimum max value, which will actually help you in reducing your blocks. Let's say there is one more block here, but it does not have this data, so it will not read this block at all. So the number 5 operations get reduced. So in this case, data can be in this block or this block, because it doesn't know. Even though you can see that, okay, 13 is not there, but it will not see. It will just go and first find in the block. It will think, yeah, this data might be available here. It has not yet started searching, so it just looks the data. So now it has to actually read two blocks when it is unsorted. Now let's say you do this as, make it as a sort key. As I told you, there will be two sets of blocks. One is sorted and unsorted and sorted block, right? And if you have a sorted block, what it does is, advantage of that is, to make as a sorted block is, you see, now the data gets, when you sort, data will be stored, the row will get stored like this: 12, 13, 14, 15. So it is evenly, consecutively the dates are available in this order. So now it maintains a metadata called 12 and 15 as a min max, and 16 and 18. Now you see the operation. Now if you give the same command, it has to only read one block, because it knows the data is in this block after reading this. So this is one more advantage of, this Redshift uses this technique. So even though column is a better concept, you once one thing is, it is a columnar format. The second thing is, you can actually reduce the size by giving some compression techniques. And the third thing is, it uses zone maps concept, wherein you can sort and unsort some column keys. So these are all column properties that you can decide when you design the table. So this will help you to reduce your basically IO operations. Okay, so this is how Redshift works, and that's why it is very fast, because it doesn't even read entire column, but it uses some methods to even retrieve and reduce the IO operations to retrieve your data. So this is how in background it works. Is there any question, or have you got the concept of this zone map?
Yeah, the concept.
Okay, so this all techniques like zone maps, okay, and your compression and your column, all this will help you in reduction of your IO operations to make Redshift work faster. Okay,
Okay.
so these
Okay.
are the concepts behind the Redshift, in which the parallelism comes into picture, and also data gets retrieved fast.
Okay.
Okay, then we'll go to this compression techniques, and I will just quickly go through it because we need to see other things. And compression, as I explained you, so there are some 7-8 compressions in this, uh, that Redshift you can use. And if you don't use the compression techniques for each column when designing a table, Redshift will automatically do for you. Okay, it will actually analyze your data, and you can it will see which columns are having a which columns. Suppose, for example, we need to decide cardinal value, so it will know the primary key. If you give yes, it will have all unique values, so based on that it will decide one compression technique. If it is date format, it will design another compression technique. It is a text format, depending on the string size, it will have another technique. So there are many techniques which could be best suited for designing your table to reduce the IO operations. So all this helps in reduction of your IO operations. So if the data can be raw, you can say that, as I told, encode raw. You can give encode as raw. Raw is default where it gets, the data gets in. It's nothing but it's everything is available as is. So suppose you have this data gets stored like this only. Okay, it is in uncompressed format. Okay, and there is one technique called byte dictionary. Okay, this is very effective. The column contains limited, I'm just reading out because I have already made notes for you. Okay, it's very effective, you can go through this. Contains limited number of unique values. So I have example given a state. So state, there could be uh, uh, so you can think, see, this also having less cardinal value. So there'll be, let's say in India there are how many states, so that many number of states only will be repeated among all the rows, or millions of rows, isn't it? So instead of storing the entire name like in Andhra Pradesh, or if it is a big name and all, and store all that information, it uses some dictionary concept where it will whichever is unique, it will try to find all the unique values, and the unique values get distributed when you use this byte dictionary. So in fact, it is what it byte means, it is 1 byte. You can think that data gets converted into 1 byte of 8 bits. So it will store the data as a byte information. So Andhra Pradesh is unique value, so it will give index of 1, then 2, then 3 for all unique values. And it will store the data something like this: 1, 2, 3 instead of full names. Okay, and if you try to search for this, it will go through this, and it will have a pair where it will just pick up the. So data gets compressed basically by using this method. Data gets compressed and data is stored in a byte format when you use this byte dictionary. Okay, this will reduce a lot of space, because if you say Andhra Pradesh, how many bits it will have, depending on number of characters, that much information would be retrieved from memory. In this case, it has to use, suppose you're searching for Andhra Pradesh, it will have to just say 1 and then pick up only that. So it will help you in your IO reductions. Okay. So these all storage techniques. Then there is a delta. So you can use this delta concept, which works actually very efficiently when you have something called a date. If you, for date columns, you can actually use this delta. So, and especially when the date is in sorted order. So if it is in sorted order, what happens is um, and if it is incremental order, for example, let's say you have some data which automatically increments the date based on the system date or something like that. So it will be having 1, 2, 3, 4. So what it will do is it will pick up the first you know the first date, and it will give the index value as 0, and then it will just say it is next index 1, 1, 1. So this is, the next one is incremented by 1, this is incremented by 1, so this is increment 1. So if you even have, so let's say after this 7 it will say increment by 2. So it will store incremental value, and this is also one concept of compression called delta. Okay, that is very effective. You have this kind of things. So while designing, you need to design in such a way based on your data. You can use these techniques. Okay. And then there is LZO format, okay, when which is highly effective when you have var car and car characters. But if you have a string which is a very lengthy string, let's say product description like this, you have, okay, very lengthy string you have. For this, you can use this LZO concept. This works very effectively actually. And then so based on your columns, you can actually give your methods, which method you want to use for reductions in size. Okay. And then there is something called mostly works on your integers and this integer columns, big integer columns. So if you have something called integer, if you store some numerical data, for that you can actually use mostly. And normally we can't decide what kind of data. Okay, we can, while designing, we know how much maximum data would be stored in a particular column, but not necessarily that every time that size of data will be recorded. So if you have decided, okay, my column should be integer, okay, which is of 32 bit, but you just store the values of only 16 bit. So if you just scan the table, there are no values of 32 bit. Then you think that there could be reasons. So you can actually decide some compression called mostly 8. So mostly, what it says, mostly if the all the columns values are less than that particular data type that you have decided, it can you can use this method of so because suppose you have used this, then it will be 16. So you can actually give as mostly 8 if you think the data would not be that much, or more data would be of smaller size, let us say. So you can use mostly. Okay. And then comes the run length. So there is one more concept called run length. If your data is actually not in sorted order, let's say, but it is in consecutive ways, data gets stored, something like color. You can be blue, next also can be blue, then green, like this, something like this is there. So what it does is it creates some dictionary. Again, it takes the I mean, first it will take this blue and it will give how many number of times it is repeating. Okay. So it says 2 times, green is 3 times, blue again next goes 1 time, and then follow. So it goes through your columns and maintains one's dictionary. Okay, which will help you. So data gets retrieved very fast when you have the data in compressed form. So your storage will be very minimal. Okay. So it stores the data something like this: blue 2, green 3, next. So you know that your record will be blue, next will be blue, then green, something like that. So it is also one more method which you can use. Okay. And then there is a text 255 and text 32. Okay, this is used for compression, like you have something called address. Okay, this is example again for address. So you have something called, it will scan through your all when you use this technique. It will find out all the values which are repeated again and again in this number of times it is repeated. So you see, for example, this nagar is repeated 1 time, your okay, maybe 2 times. Okay, Hyderabad also repeated 2 times. So it will find out all the values which are repeated, and then what it will do is the all the unique words of such will be put in a dictionary and given one ID called 1 and 2, and the final data would be compressed in this form. Final compression would be something like this. So it will say this 3656 ram at the rate 1. So at the rate 1 is nothing but nagar, it is referring to as nagar at the rate 2. So when data gets compressed and written in this form, and there is some dictionary ID maintained where when you search for this data, it will use this technique to retrieve your data by this compression. So entire aim for all this is you can decide what kind of compression you want. So something works best for one column, some works best for another column. It is all depending on you, how you design your table structures. Okay. And again, there is one more something called Z standard. If you have some long and short strings, one string is very long, one is very short, or something like that, you cannot. There's a various proportions. Then you can have one more standard called Z encoding standard. Okay, but maybe that's not so useful. But anyway, there is one more concept called Z standard. Okay, and if you already know about this documentations, you have already gone, so you can, if you want to understand more, okay, you will not find this kind of examples, but of course it will help you in understanding more about the encoding when you actually start creating your tables and all those kind of things. Okay, this will help you in understanding more better way, which one will work for what, like delta. Okay, you can use delta for these things, so you can go through all this to understand more if you want to understand about compression. Okay, this will help you in when you're designing the tables and structures.
Okay.
And also there is one example is given, so you can just go through that. Fine. So you understood how the compression works and what kind of techniques you can use when you are designing,
Yes, Raj.
and
Yes.
how data gets compressed and stored in like byte means numerical byte to one single byte format.
Mm.
So it will be that's how this Redshift works. Okay, by
Okay.
using this
Yeah.
compression techniques. So this is all
Mm.
about these concepts and encoding, how the Redshift works and what are the advantages, why Redshift is fast.
Okay.
Okay, so if you have understood the architecture, that is good. Okay, and this already I have discussed. How the query lifecycle takes place when you give a query like count star or something like that from your client application. This query gets first goes to the lead node. Okay, and it passes your query. It prepares one execution plan, and that plan will be sent to your different compute nodes parallelly. Okay, at the same time it will send to all this. So what we'll do with this compute node is we'll do the aggregate and you remember this, based on the block and all compressions, everything will come into picture in this case. Okay, so compute node, it will try to compute that whether sum or count or whatever it is, each one it will do, and then the intermediate results will be sent back to the lead node, and which will do the aggregate functions, like it will collect all. Let's say you're doing a sum of some particular column. Okay, so it will have one sum, this will have another sum of that column, so everything gets aggregated again, and then final result would be sent to the client application. So this is an overview of how the life cycle of Redshift works. So basically everything is done parallelly, and I explained you how there are some components which it uses, like parser and rewriter, and then it will optimize the code and send as C functions. It will there's a compiler involved, and second time when execute the query, it is already compiled, so results will be more faster. Okay,
Yeah.
okay. Then we'll just start working on the Redshift and just see what is a user account. We already gone through that, so I don't have to explain much here. Let me know if you have not understood anything here. So basically you have an account. Okay, now you already have an account. So with that account, what all things you can do? So with that account, if you have to work with Redshift, you can create a cluster. Okay, uh, so cluster will have a database and nodes. Okay, and then you have the users created in that account and give access permissions using some IAM service to connect to your database or Redshift. Okay, that is if you want to connect like this, means it is nothing but giving permissions through this IAM role to get connected to your Redshift. Then you have some VPC security group permissions, wherein you can allow your other client like SQL workbench and all to connect to this. So it provides one JDBC jar file which you need to download based on whatever client, whatever database you are using. Okay, so this is just an overview of how the things look in terms of how data gets accessed from outside or inside. And of course there is one S3 also, which is not here, but S3 also, you can ingest the data from directly from here to Redshift.
Okay.
This is when you're talking this is only through your client. Okay, and then there is one S3 from where this is storage, from where data gets ingested. So you have already gone through these steps, right? I don't have to explain this. Is that correct?
Yes, correct.
So you have already gone through this. Anyway, these are all the steps. This is for somebody who has not gone through, and I could have walked through, but you already gone through this, so I don't have to explain
Yeah.
this, isn't it?
Yeah. Yeah.
Okay.
Yeah.
Okay. Then we'll come to the softwares. Okay. What are the softwares to be used with your Redshift?
Right.
So if you have not done proper installations, there is a likely chance that something may not work, right? So
Okay.
you have
Yeah.
said about SQL Workbench. Okay.
Mm-hmm.
So uh, I think also from where you need to download, but this is the path from where you can actually download your SQL Workbench. So what all things we
Okay.
require is nothing but you need an SQL Workbench to again.
Mm-hmm.
If you need an SQL Workbench, you need to understand. There's a prerequisite that you need to have your Java installed, JDK installed, execution engine. That
Oh,
means uh, JDK 8 or Java 8 you need to install. Okay.
okay.
So first you need to install Java. Okay.
Okay.
That is a runtime engine, and
Mm-hmm.
that Java 8 basically, and then you can it will work with the Workbench. And
Okay.
for this you need this JDBC connection. Okay, there's a jar file. So also when you create a Redshift, it will create one JDBC string which you need to always copy and keep it with you,
Yeah,
and
we
this
need
will
to
help you
copy
to
to
connect.
that. Yeah. Yeah.
Okay, I think you know all about this.
Yes.
Correct, no?
Yeah.
Okay, so let's see how it looks then. Okay, um,
Okay.
in my computer, I already installed Java. Okay,
Okay. Okay.
I'll just show you so that it'll be easy for you to also locate if in your system there is something wrong.
Okay.
I'm just going to the control panel and to this programs. Okay, and you can see here Java 8
Yeah.
installed. Okay, and I just installed recently only. You can see that, so that you just to see that it is working fine.
Okay.
So you just go
Yeah.
to the link, you just download it properly. If it is 64-bit and 30-bit, you need to be careful what exactly your work. My system is 64-bit, so I have installed Java 8 of 64-bit. Okay, so you
Mm-hmm.
need to have this installed first, and through S3 browser, I told you, right? So there is one S3 browser also. There is, when you download, you can just install using that. It will have one more S3 browser coming over here.
Okay.
So I can launch the S3 browser since it is already installed. Okay, I'll not go
Java
through these
also
steps. Sorry,
Java 8, right?
Java.
Yeah, I have the Java 8. We should
Okay,
use
you
that.
have. So yeah. What I'm showing is you can actually
Yeah.
see in your computer where the settings are already available.
Yes, sir.
So if you
Okay.
have Java
Yeah.
8 installed, that is very good. That means your SQL Workbench will work.
Okay.
So that is a prerequisite for SQL Workbench, I'm saying.
Okay. Okay.
Got it?
Yeah,
So
got
these
it.
are nothing. This just two things you need to just show. Workbench is nothing, but why it is not there? Because it will just copy a folder. That's all. You don't have to have
Okay.
a proper installation for. You just
Okay.
distribute the zip file and everybody can use it. Okay.
Okay.
So
Yeah.
if you have seen that and everything is set up, so this is SQL Workbench, which this is zip file directly. You can go through the link. Okay, it will just get downloaded. Okay, directly I have given the path itself where you can just download it. Okay,
Okay.
and then once we have the workbench, it'll have a zip folder. I mean that zip file. That zip file I have just uncompressed it. Okay, I think I have in downloads. Yeah, so in this downloads, I downloaded this zip file and one S3 browser. Just I try to
Okay.
collect. Okay, there's a Java.
Mm-hmm.
Sorry, this is a JDBC driver. Okay, this is the
Okay.
runtime engine Java, and I have
Okay.
just downloaded Notepad also just for using some commands and
Notepad
all.
plus plus.
If you have Note Plus, I suggest you have this. This is very very useful. You know,
Okay.
instead of
Yeah.
Notepad text editor, if you have Notepad plus plus,
Yeah, it should be better.
it is very good for your HTML reading. It will just parse so many of the things. So
Okay.
it is very good actually if you have this Notepad plus. Okay, you see what are things I have downloaded? Nothing much, right? To work with this,
Yeah.
and it's very easy. So just need to have workbench. So it will be a zip file. Okay. So once you unzip it, I have this folder called workbench.
Okay.
Okay. And this is the thing. So there's no installation, nothing. Just copy that, and you'll get this. Okay. Then there is a
Okay.
64-bit and a 32-bit. So it gives both of your depending on your system. So you can connect through 64 or 32. Okay.
Okay.
So just you need to just start this. And one more thing, as I told you, for workbench, you need, okay, you already have the Java, then you need the jar file, okay, for JDBC
Mm-hmm.
driver.
Okay.
So do you have the JDBC driver? For that also the
No, I
path
need to
you need to
do it.
download.
I will. Yeah, I will do that. No issue.
Okay, you can download that later. Okay. So once you have that,
Okay.
what I try to do is instead of keeping in some folder and giving, I gave that jar here itself,
Okay.
Redshift JDBC. You see, it gives,
Yeah.
if you go through the documentation, it has already given the link there. Actually, I use that link
Okay.
only to download.
Oh,
That same thing only I've
yeah,
given
I
to you.
have that. Okay. Okay. I have that.
You have that, no? Good. So once you
Yeah.
have that, you can actually put anywhere in any of the folders, but I just kept it here just for my convenience. Okay.
Okay. Okay.
I just
Mm-hmm.
copied it there. And then I started the SQL. So now it is something like, we are working something here. Okay.
Okay.
I have an SQL. But for that, I
Mm-hmm.
need to have a account, and I need to have some cluster already this thing, and I need to
Yeah.
also have a access permission to connect to my Redshift. Already, since I have done one setup, okay, I am just showing you how to connect to that particular node. If you already created one cluster, it will be helpful. Directly, you can see
Yeah.
how it works. Hmm?
Okay.
Have you worked with SQL Workbench before?
No, 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 no. I have not worked with that.
Okay,
I worked in storage area network actually.
sorry.
Storage area SAN. I worked in SAN.
Okay, this is very
Yeah.
easy. I mean, very simple client. Okay, you can just explore the various options here. We will not go through the options of SQL Workbench, but I will show you what is used, what you will be using for your usage. Okay,
Okay.
so once you start your SQL Workbench, okay, you will get something like
Mm-hmm.
this. So
Yeah.
you need to create one
After
profile.
clicking on that file. Okay. After clicking on that file, we will be getting this window, right?
Yes, yes. Again, I can start.
Okay.
So what I did is nothing
Okay.
but I just went to here and just I have a 64-bit. Okay, this is 32-bit.
Yeah.
This is application. Okay,
Mm-hmm.
there is one more. Actually, it is better if you have this, extensions.
Dot exe. Yeah.
Yeah, if you have these extensions available with you, it is very easy to check whether it's a exe jar file, instead of reading the type here.
Okay.
So I
Okay.
suggest you keep that properties. I think it is in view. And what version of Windows you are using?
It's 7, I think.
Okay,
Yes. So no, no, it's 8.
8. Yeah, mine's also 8. So you can go to view and just see this, file extensions. You can just keep it on. So it is always going to help you to know, see, because both are looking the same. So if you have this, it will be very easy to
Yeah, I have
understand
that.
whether it
Yeah,
is
yeah.
easy or not.
File
Just,
name extension.
yeah, yeah,
Yeah.
you can do this. So this is some helpful, usage, which normally I use.
Uh,
So I can easily see directly here, okay, this is a XML file, this is a command file, something like this. Okay,
Okay.
this user
Yeah.
preferences based on your usage. So what I did just is I was showing you. You just used. I just double click this. That's all. Again, I'm doing
Oh,
this 64-bit. So yours is 64-bit, I believe. Then so you just double click that.
okay.
Hmm? So you will find something like this opens here.
Mm-hmm.
Okay, and you by default this is already I configured it, so it's not there. What I can do is I can simply delete this entry. You will not find this here. I'll save this probably. I will start again just to see. Okay, see now that profile is not there. So when you open it, it will open something like this. Okay,
Okay.
you can give any name to it. Okay, Redshift or something like that. Okay,
Yeah.
and then oops, my mouse. Hold on. Okay, it's come. So just give the profile name. Okay, and then what you need to do is before actually giving a driver, you can see that okay, since I already have that. See, before one more thing will happen. Why I told that my Redshift is here. Suppose my Redshift is not here. I removed it.
Mm-hmm.
Okay, so this is normal setup. Okay, which you just install and you have the setup ready.
Okay.
Okay, still it is already there because it maintains one XML file. Okay, so this is
Yeah.
automatically come in. This normally you will not find. I think if you just start Workbench and install, this will not be actually available to you. Okay,
Mm-hmm.
so basically what I'm trying to say, you will not see this when you have a fresh installation. Okay, why
Okay.
this has come? Because I copied that into the same directory where this SQL Workbench was.
Okay.
I'll just try to copy it again. Downloads. This is my jar file. Okay, I'm just trying to copy this file again back to my SQL Workbench.
Mm-hmm.
So I'm just trying to copy in front of you. Okay, and
Okay.
I just started this. The first thing, okay, you need to just give a name as I told. Anything you can give. Okay, then you just go to manage drivers.
Mm-hmm.
In manage drivers, okay, even though this is automatically come,
Okay.
it is already configured because actually it shows the data when you work. So I'm just deleting that again. So you can what you can do is just one this thing will come automatically there for you. In fact,
Mm-hmm.
um, you can give a name. You can actually create here. Okay.
Yeah.
You don't. Why don't I create one more? So I just create one more. I'll call it as, let's say, Amazon. Okay.
Okay.
Redshift. Uh, JDBC, because it says it's already there. That's why we have a warning. Okay. JDBC driver. So I'm trying to create, one this thing. I just trying to give a name and I'm just trying to load the jar file here. So just go to this place. As I told you, you can have anywhere. So it opens the normal wherever you're working. So since I have it here, I'm just selecting and opening it. Okay. So automatically it'll just select some class name and some sample URL which is of no use. I mean, just a sample how it needs to work with. Just leave it and just say okay. Okay. So if you do that, you see, it will come here. Got it?
Yeah.
You can again see that how it is there. So this will come, and now this will be available for you here. So you can have n number. See, I just removed it because I deleted, so that has gone. So this is not there. Now this is the current one. Got it?
Yeah.
So just select this, and then this is a URL. This URL is nothing but your JDBC
JDBC.
string.
Yeah. Yeah.
Okay. Since I already have my JDBC because I already created a cluster.
Mm-hmm.
Okay. I'm just trying to copy the string, whatever I have. You need to note down this. Okay. And
Yeah.
properly just paste it here. And when you create your cluster, You said you already created
Yeah.
it. You will have some
Yes.
user. I have something called m user. I have given name,
Yes.
which will actually help you to connect to your database. And I have given a password, some password with the m user. Okay.
Yeah.
I'm
Okay.
just typing that password, whatever password is there. So you need to have. So you just go to manage drivers, create a driver, give the link to this jar file, and give your
Yeah.
string, give username,
We'll be
password. Got it?
okay.
And then say auto
Yes.
commit. Yes. This is
But
actually useful.
okay. So what it says, I mean, if we click on that auto commit, so it
The
will be
auto com
taking the. Mhm.
auto commit will actually, if you don't use this, what will happen when you create a table? Okay, when
Okay.
you try to insert some rows. Okay, when you update
Mm-hmm.
something, when you delete something.
Mm-hmm.
Okay, and if you don't commit, what happens? Your record may get lost. Okay,
Okay. Yeah.
so auto commit is that means you want to commit every time when you do some insert operations or this kind of operations,
Instead
update.
of that, we need to click here.
Yeah, auto commit means as soon as insert command is there, it will just do a commit automatically for you.
Okay.
Otherwise, you have to just use the command called commit
Okay.
for after every statement or after bunch of statements, you can give a commit.
Okay.
Okay, so
Yes.
basically for reducing your IO operations, you can ignore that. But I advise you just to have a auto commit for your usage.
Okay.
Sometimes Redshift will give some errors. It will not try to insert if you don't have this auto commit.
Okay.
Okay, you can experiment with that, but recommendation is to do an auto commit here. Just give a check mark here,
Okay.
and remaining
Okay.
all things you just forget about it. Okay, keep as
It's
default.
default. No
Yes,
need of changing it.
no need of changing any of the things. Just use the auto commit option here. That's all. And
Okay.
then there is something called test. So whatever connections information you have given, whether it is successful or it will not be successful. Okay, you can do before even actually going into that errors. You can actually do a test here. So just click on
Okay.
test once. So it is just trying to connect to database.
Database.
Okay, since my string was correct.
It's
Okay,
successful.
and your
Yes.
username was correct, password was correct. So it's saying it is successful. So this
Okay.
is how you actually connect from your SQL client to your Redshift.
Redshift.
Okay,
Okay.
now this test is successful, so I can proceed now. I can just click OK
Okay.
here. Okay, I have some bunch of commands, but what will happen is you don't have these commands, so you'll get all this empty tab. Okay, something like
Mm-hmm.
this you'll get.
Okay.
So this will be your first tab. Okay, where sure. Okay, so this is how you'll get your screen once you
Okay.
start. And you can just start creating your tables and all those kind of things. You can start working on it directly. Okay,
Okay.
so once you come over here, for there is one more thing called database explorer. What you can do is on this, you can click this and just say add a db explorer. See, db
Okay.
explorer is, it will actually show you all the tables and structures all available in your database.
Mm-hmm.
So this is a tool, inside that which will help you in knowing, what kind of tables and all are there. Okay.
Okay.
So you know about schemas, right?
Yeah.
So a database will have a schema and a schema will have tables. So by
Okay.
default, there is a public schema. Okay. That is given for users to create their own tables. And you can create your own schema and all. There are different commands for, create schema, you can give and then permissions and all. But and you can under that you can create users and start working, but by default there is a public which I'm using. Okay, so in that
Okay.
you okay, so you see that there are some three tables in this. Okay, I
Mm-hmm.
have created some tables and there are three tables in this. and they're all under public schema, and this type of this is table. So if you just see customer table, some sample table I created. So this already I have set up, so I'm just showing you how it will look. Okay, once you
Okay.
have this kind of
Okay.
setup, I could have started
Mm-hmm.
from beginning, but I'm just showing you whatever I have so that you can understand how the things looks. Okay,
Okay.
we'll see how to create and how to do that when we start with practicals from tomorrow probably. But I'm just showing you.
Sure.
When you create, you can find these tables here, and you want to see, what are the columns you can get. Like this, a tool you can get all the information, right?
Yeah. Yeah.
And you see the SQL command for how it is created, that create table. So you can just see what is the syntax for that, how this was created.
Okay.
See, create table. So it will just generate the syntax for it also for you.
Mm.
Okay, and you can see the data if any data is present in this particular table or not. So I just inserted some data now. That's why you are able to see this data. Okay,
Mm.
so this is
Okay.
usefulness for your database explorer if you have it.
Okay.
Got it?
Yeah,
So
got
you can see here it is already connected. That's why you are getting this. Suppose it is not connected,
it.
then you will get something like you can okay, and you can click here file and just reconnect if there's some problem, let's say not working, or you disconnect this window. Once you disconnect this
Okay.
window, you can see that there's no connection now. So
No connection.
connection is gone here.
Mm-hmm.
So again, if you want means you can go to this connect window. You will get this dialog again, and this is automatically set for you. You don't need to test because already you tested once, and just do a connection here. So it is going to connect to the
Okay.
database, and once your connection is established, it will just show you here. So you see, this is dev is nothing but my database, and this is my user.
Okay.
Okay, I'm using a public schema, and this JDBC and all these things you can see. And test is my cluster name actually.
Okay.
Okay,
Yeah.
so this is how a client looks, and this is how you can connect to uh, your Redshift from your client with
Fine.
Workbench. So if you have done your steps properly,
Yeah, I will
uh,
do that. I will do that tomorrow, and I will do something. I mean, as you've shown to me, I will
mhm.
work out and on my laptop, and I will do that.
Yeah. So this is very easy. Okay, you already have this Java 8, so there's no issues. Just download this SQL Workbench, and
Oh,
for this also you have the path, right? Eh, you
yes,
don't.
I have that. Yeah.
Yeah, you have the path directly in your documents. It is there. So I use that path only and copy it from there only here. So
Okay.
okay, so that you can directly download,
Fine.
and
Fine.
that's it. And then JD, so you have cluster already. You said right.
Yeah, yeah. I set the
So you have
cluster.
this link also, JDBC.
Yeah,
Uh,
everything I have. All the links in the document, I have that.
Very good, very good. Then you
Yeah.
experiment and just use your SQL Workbench and see whether you are able to
Yeah, I'll do that.
successfully
I'll do
connect.
that.
But follow the steps
Sure.
whatever
Sure.
I showed you so that you will not land into any problems.
Yeah, Raju, can you send me this document because
Uh,
we completed this? If you send that, it will be, I mean, helpful for me.
okay. Uh,
Yeah. What is this
uh,
Excel? Once you
yeah,
forward to me,
as
which
I told, I
document?
don't have any issues. Let me talk to Chandu once, and if she wants to
Yeah,
send,
you
I
talk
don't know
to him.
because I have not been
Okay.
sending the documents. Chandu is taking care of all that thing.
Fine
Hmm?
then. I will check with her. Yesterday I forgot to check with her. I will
Uh,
talk to her then.
yeah. Please talk
Yeah.
to her. For me, there are no issues. This is all for you only. Okay, all this
Yeah,
information
yeah.
is for you only.
Okay.
Hmm?
Fine,
So
fine then. I will check
tomorrow
with
we'll
her.
see. We'll see the S3 also, how to connect through S3 and how to give the commands from S3, and we will start working practically tomorrow with all the commands.
Sure, sure. Yeah.
Okay. So
Okay,
any
done.
doubts or
Yeah.
questions for today's session?
No, Raju. As of now, nothing.
Okay, good. And do practice, and it is good if you do
Sure, sure.
practice.
I
You
will do
will
that.
come to know a lot of
Yeah.
things. Hmm?
Yes, correct.
Chalo.
Yeah, I'll
Hey,
do that.
chalo. Thank you.
Chalo. Yeah,
Have
thank
you?
you. Bye.
Yeah. Bye.